Okay, millions of they're just posting, right? So we see like what is the data generated by Facebook in a minute. Not only Facebook, right? Today, if we talk about any application generating huge data, right? If I talk about 1 minute transaction, if I just take 1 minute transaction itself, they are generating huge data, right? For example, Facebook is the one. Data generated by Facebook in a minute, millions and trillions of users making multiple transactions. Okay. Here, Twitter tweets keeps on generating. And if I talk, you are querying in the Google, right? Google queries. If you are Google queries, so huge data. What is the data generated by Google in a minute? Or you are creating your own videos and uploading in the YouTube, right? YouTube videos upload. What should be the storage capacity to store all the videos? Or if we talk about millions and trillions of users using email messaging, right? Email messages. And what should be the storage capacity to store all these messages, right? And if I talk, just now I was talking about bank transactions. Bank transactions, right? Like lakhs of branches, billions of customers making transactions. Similarly, for telecom transactions. Or if I talk about e-commerce sites, right? E-commerce websites like Flipkart, Amazon, right? They're generating huge data, right? So currently, if I say like we have got databases, right, for storing this data. Currently, we are going with databases like we've got databases like Oracle, MySQL, SQL Server, right? So DB2. So these are used for these databases, etc. All these are used for OLTP, online transactional processing for day-to-day operations. OLTP, right? Online transactional processing for day-to-day operations. And even we've got some specialized databases, right? We've got some specialized databases that are used for data warehouse purposes, like Teradata, Netija, Vertica. So these databases are used for data warehouse purposes, DWH, OLAP purpose, right? Yes. Analytical processing, OLAP, online analytical processing, right? Okay. So databases and specialized databases, right? But they can handle data up to some extent, but huge data, unlimited data can't be handled by this, right? So so as a solution to all the storage level problems, not only storage level problems, right? Even we need to process that huge data, right? So we have got a framework like Hadoop for huge data, unlimited data storage, huge data and unlimited data storage, right? We have got framework like Hadoop. So this meant not only for storage, it is also meant for processing. I'll come back to this Hadoop and its services, right? But before that, how this data is getting generated and what are the various sources and types, right? Assume this is your data which got generated from the last 50 years. This is your data which got generated from the last 50 years, right? 1972 to 2022, right? If you observe this, 1972 to 2012 and 2012 to 2022, last 10 years of data. This is last 10 years of data. Nearly 80% of the data has been generated from the last 10 to 15 years, and previous 40 years, only 20% of data. It's very less data, right? What is the reasons for this huge data generation? What is the reasons for huge data generation, especially from the last 10 to 15 years? Because of usage of technology, usage of smartphones, because of usage of technology, usage of smartphones, and usage of internet. Usage of internet has increased a lot, right? And usage of smartphones has increased technology also, right? Because of which huge data is getting generated. Previously, going to 1990s, right? If you see 1990s, the second, see how the data, we used to see floppy disks. 1.44 MB. You used to carry data in floppy disks, 1.44 MB. Later you got compact CDs in MBs, like 700 MB, later like DVDs like that. So here, as data is increasing, even the storage capacities also need to be increased, right? So here, what are the main sources? Main sources from where this data is getting generated. I can say mainly three sources of data here. I can say mainly three sources of data from where this data is getting generated, like social data, machine data, and transactional data, from where this data is getting generated, right? Social data, data which got generated from social websites, right? Like Facebook, Twitter, all this. Machine data, data which got generated, right? By reading or scanning the barcodes, RFID chips, all this, such kind of data we call it as machine data. For example, if you go to a shopping mall, for the items you purchase, right? You will get a big bill, right? For items you purchase, you will get a big bill, right? So the data which got generated by reading or scanning the barcodes or RFID chips, such kind of data we call it as machine data. Transactional data, day-to-day operations, data which got generated from day-to-day operations, bank transactions, telecom transactions, right? Yes. So, and these three types of data. Structured data, yes. Semi-structured data, unstructured data. Structured data means data which is organized in the form of rows and columns, right? Excel sheets, database tables. Semi-structured data, which is not fully structured, which is not fully unstructured, which is not fully structured and which is not fully unstructured, like XML files, JSON files, right? All this comes as semi-structured, right? Yes. Unstructured data like chart messages, articles, images, videos, all this comes as unstructured. So the biggest challenge today, right? So most of the data what we see is in unstructured format. So storing this and processing this unstructured data. So we need to store this unstructured data and process this unstructured data. But databases can handle only structured data. They can store structured data, but biggest challenge, but Hadoop can store and process all varieties of data, structured, semi-structured, and unstructured. So day by day, as data is increasing enormously, we need to have proper storage systems and processing systems, right, to store and process this huge data. As a solution to all the storage and processing level issues, so we have got a framework called Hadoop. 1 second. Hadoop is meant for two things. Hadoop is meant for storage and for processing. Hadoop is meant for storage and processing. Generally, if we talk about any technology, C or C++ or Java, right? or .NET. They are meant for processing. Oracle or MySQL or DB2, all these they are meant for storage. So if you take any technology, they are meant either for storage or for processing. Either they are meant for storage or processing, but Hadoop is meant for both storing and for processing. Hadoop is meant for both storage and processing. For storing the data, does Hadoop use any database internally? Does Hadoop use any database for storing its data? No. As I was saying, like we have got some drawbacks with databases. Despite with the drawbacks, right? Still, Hadoop doesn't use any database for storing its data. It is going with a special kind of file system called as Hadoop distributed file system. Storage and for processing. Hadoop is meant for storage. So Hadoop doesn't use any database for storing its data. It is going with a special kind of file system called as Hadoop distributed file system. And for processing, we use MapReduce Spark. Yeah. Hadoop is meant for storage and processing. Yes, Hadoop. For storing the data, we are going with a kind of file system called as Hadoop distributed file system, and for processing, MapReduce and Spark. So here I got a couple of queries, right? So when Hadoop is able to perform both storage and processing, what is the necessity of this processing and storage technologies? Do you think when Hadoop, do you think this storage and processing will go away, right, from the market? So we need to understand Hadoop is for what purpose, what kind of applications we can develop by using Hadoop, right? Hadoop meant for storage and processing. For storage, HDFS, and for processing, MapReduce or Spark. So Hadoop is meant for batch applications. Hadoop is for batch applications. Hadoop is not for online applications, right? So for if you are making a single transaction, right? If you are making a single transaction, Hadoop not required. Hadoop is not required. For millions and trillions of records, right? You can go for Hadoop, but single record or two records, right? No, you can go with the databases, right? So batch applications, millions and trillions of records, storing and processing, go for Hadoop, right? Batch application. So there are a couple of queries, right? And why databases are not chosen to store Hadoop data? Why we are going with a special kind of file system called Hadoop distributed file system? What are the drawbacks we see with the databases? Drawbacks with current databases, right? Just to check this. Drawbacks with databases. So most of the databases, limited storage, no parallel processing, limited storage, no parallel processing, right? most of the databases, we cannot go with huge data storage, right? In most of the databases, no parallel processing we are going to see, right? And if you observe, if volume increases, speed decreases, right? Yes, speed decreases. If volume increases, speed decreases, right? So for example, if I'm taking some SQL query, right, select sum of amount from sales one, select sum of amount from sales one. Yes, select sum of amount from sales two. Yes, sum of amount from sales one, sum of amount from sales two, right? Yes. Sum of amount from sales three. Total amount from sales one, total amount from sales two, total amount from sales three. Sales one, sales two, and sales three, right? Yes. Sales one has got 10 records. Total amount 1 lakh records. One crore records, right? Total amount from sales one, 10 records. Total amount from sales two, 1 lakh records. Sales three, 1 crore records. Which query is going to execute faster among these three, right? Total amount from 110 records, or total amount from 1 lakh records, total amount from 1 crore records. So total amount, so obviously the first query executes faster, right? So total amount of 10 records as compared with the total amount from 1 lakh and 1 crore records, right? So here, yes. So query to query as volume increasing, speed decreasing, right? Query to query as volume increasing, speed decreases, right? Yes, the first query executes faster as compared with other one, right? Apart from that, even if you see, if complexity increases, right? Speed decreases. In databases, right? Complexity increases, speed decreases. Observe. Select. Select sum of amount from sales one. Next, select average amount from sales one. Select standard deviation of amount, right? Sum of amount from sales one, average amount from sales one, standard deviation of amount from sales one. Standard deviation of amount, right? So all that got 1 lakh records, right? Assume that you got 1 lakh records. So which query executes faster among these three? So obviously the first query, right? So first query, because second query is average amount, is a two-step process. First sum to be calculated, next average need to be calculated. As compared with the first query, second query takes more time. and standard deviation of amount, lot of internal processing required. Standard deviation of amount, right? Lot of internal processing required, right? As compared to that, yes. Sum of amount from sales fund, average amount from standard deviation of amount from sales fund. So as complexity and major drawback with databases is databases can handle only structured data. Databases can handle only structured data. The databases can handle only structured data. They cannot handle unstructured or semi-structured kind of data. For example, just observe this. I want to take reviews for a particular movie, right? Yes, reviews. Table name, right? I have got a table like this, right? User and review. User and review. User 1, user 2, user 3. 100 users giving reviews. First person saying the movie good. Second person saying movie 0 indicates bad. Not good. Good, not good. Good, not good. They are giving a feedback in the form of zeros and ones, right? Zeros and ones. 1 indicates right. 0 indicates bad. So can I write an SQL query to count the number of goods and not goods? Can I write an SQL query to count the number of ones and zeros here? Yes. I can handle this kind of data, right? Select count aggregation. Count aggregation, right? Single grouping, single aggregation. Select review wise count star. Review wise count I want from reviews. Group by. From reviews, group by review, right? Yes. Review wise count I want from reviews, group by review, right? Yes. Output review wise means review 190, right? 90 people saying it's good, 10 people saying it's bad, right? So 90 people saying it's good, 10 people saying it's bad. Okay. But generally reviews won't be given in the form of zeros and ones, right? If they're giving in their own text format, movie is good. Second person saying movie is not good. So in this way they are giving in their own, right? So can you write an SQL query to count the number of goods and not goods? Can write a query to count the number of goods and not goods here, right?
It is possible, but the test data compulsory will not change.
So it's not possible, right? But even if you say by using keyword count,
Yeah.
by using keyword count also, if you perform right, even it gives wrong computation, because Even not good is having good within it, right? So it goes wrong, right? Yes. So this kind of data can't be handled, right? So databases can handle only structured data. So unstructured or semi-structured kind of data can't be handled. So these are the drawbacks with the databases. So Hadoop going with a kind of file system called as Hadoop distributed file system, right? Yes. Hadoop advantages, right? Hadoop advantages. First one, unlimited data storage. Unlimited data storage. Secondly, right, very high speed processing. Very high speed processing, right? Yes. And can handle all varieties of data. Can handle all varieties of data. Unlimited data storage, very high speed processing, can handle all varieties of data. And it's an open source, right? It's an open source, no licensing required. Most of the products are from Apache. Commodity hardware, right? Like very highly configured systems. So Hadoop can run on any systems, right? And any hardware, commodity hardware, right? Unlimited data storage, very high speed processing, can handle all varieties of data. It's open source commodity hardware. So very high speed processing means there was a test. So there was a test conducted, right? Yes, just observe this. Yahoo conducted a test. Yahoo conducted a test, right? To check the speed of various databases by taking a table, has taken a table, right?
So it supports parallel processing, right?
Which one? Yes.
It's up, yeah.
Very high speed processing because of parallel processing. So parallel processing, right?
What is the meaning of commodity hardware?
Commodity hardware means Hadoop can run on any hardware configuration, right? It doesn't mean that very high configuration required, not like any systems, right? And it doesn't mean that all the systems need to have same configuration. No, it can run on any system, any configuration, right? Yes. And okay, it is an open source, no licensing required. Most of the products we take Hadoop products, right, from Apache side, and can handle all varieties of data, structured, unstructured, and semi-structured kind of data. Very high speed processing because of parallel processing. Unlimited data storage because of there is a feature called horizontally unlimited scalability that I'll be discussing in brief, right, in the tomorrow session. But I'll be just briefing you about all these advantages, right? So tomorrow also you'll be attending, just to attend the session to see more on this, right? So tomorrow I'll be just briefing you about these advantages. Why only Hadoop can go with unlimited data storage? Why not databases? Why only, and why Hadoop has got very high speed processing? Okay, so I was giving an example, right? Yahoo has taken a table of 100 TB consisting of 1024 columns. The task was sorting. Sorting based on 16 columns. Sorting based on 16 columns, right? So what is the time taken by different databases? Time taken, right? Different databases. So here, Oracle has taken nearly 3.5 days, right, to process this, and MySQL MySQL, right? It has taken nearly 6 days to process this. 6 days, right? Yes. But we have got some specialized databases like Teradata, which can handle huge data, right? Like TBs of data. It has just taken 4.5 hours to process that. And when more specialized databases like Netija, it has just taken like 3 hours to process it. And finally, Hadoop has just taken 3.4 minutes, right? 3.4 minutes to process it. But latest version of Hadoop, just 1.2 minutes, right? Yes, 1.2 minutes. So this is what the speed of Hadoop, right, as compared with the other things. But Spark has got very high speed rather than Hadoop, right? Spark has got very high speed processing because of in-memory computation, memory level storage, and memory level processing you are going to see. Yes. So this is what Hadoop proven in the market, storage point of view and processing point of view, right? Processing point of view, very high speed. Storage point of view, unlimited data storage. Okay. So what I'm going to discuss as part of this course, right? My more concentration will be on Spark and Scala, right? So in Hadoop, some important components I'll be discussing more. And there are some components which are outdated. I'll be just giving you knowledge on those, right? So here, so introduction to big data, challenges in big data, comparison with other technologies, HDFS, Hadoop distributed file system, right? And MapReduce. For processing. So it is Hadoop development training, right? Yes. Most of that will be concentrating on Hadoop development, right? Hadoop administration also will be discussed, but most concentrations here will be on development side. So here, MapReduce meant for processing is a parallel execution model, right? And Scoop for import and export operation for pulling the data from databases, right? To Hadoop, again from exporting data from Hadoop to databases. Scoop import operations, right? Scoop import SQL plus Hadoop. Yarn, yet another resource negotiator, right? So there were some architectural changes, right? And there were some previously some problems within this Hadoop 0 and 1 versions. Everything got rectified from 2. So we call it as yet another resource negotiator. So in Yarn architectural components, yes, please be in mute. Yarn architecture and Yarn components, Yarn how the processing is going to happen. Pig, it's one more processing component, right? It's a data flow language. We use like pig scripting. So, and also next is I am discussing Hive component, right? Hive is an important component of Hadoop, right? Which is used in every project. Like it's a kind of data warehouse kind of environment in Hadoop framework, where we'll be creating tables and perform querying, right? We'll create different types of tables, internal, external, partition, non-partition tables, right? And here we'll be loading data. We'll be creating tables, working with XML data, working with JSON data, URL and web block data, for unions, joins, like inserts, inserting into local files, UDF, user-defined function, user-defined aggregated function, user-defined tabular functions, non-partition tables, static partitioning, dynamic partitioning, right? Multi-column partitioning, bucketing in Hive, indexing in Hive, right? Combination with bucketing, indexing, index and bucketing, partitioning and bucketing, partitioning, indexing, partitioning, bucketing, indexing as a combined, right? Performance tuning mechanism, right? And NoSQL database. At least you need to have knowledge on at least one NoSQL database. So what are the different NoSQL databases? What are the differences between them? And we are going to discuss one NoSQL database like HBase. And coming to this Spark Scala, right? Before the Spark, I also discussed like streaming data and technologies like Flume, Kafka, right? And
Sorry,
also like
above Spark and Scala is the admin part or configuration part. what exactly it is divided actually. Like in the normal application based upon Java or .NET or C Sharp, whatever you call, whichever technology, or maybe Python, whatever. Or so our front end is UI, any UI, Angular or whatever you are using. Then the business logic is written in C Sharp, Java, or whichever language you want, right? Then it is connected, bind with the database, right? And for database, we can developers uses normally PL SQL and all that stuff. So how exactly it is used? So how it is divided? Is this the configuration part or the admin part, or how what exactly
Yes,
the above part is actually? That is what my ask is
so
about.
Akshit, right? Akshit. So
Yeah, yeah.
here, one thing, there are two types of applications: online applications and batch applications. Whatever you discussed are for online applications. Online applications, that is what client server architecture you follow there. Client server means request response architecture you follow, like whatever is in Java, .NET, Python, like MVC architecture, MBT architecture, right? MVC in Java, MBT in Python, right? So those are for online applications, like request response architecture, right? Client server architecture. Those things we are not going to follow here, right? In this big data Hadoop or Spark, right? We follow master slave architecture. Tomorrow I'll be briefing you about that basic architecture of Hadoop, right? Master, single master, multiple slaves. It's not like request response. You're giving a request, getting a response. Hadoop is not for online applications. Hadoop or Spark, right? They're for batch applications. Batch applications means user, you see, user interactive applications. That's online applications. User interactive applications means user gives the input. You are booking a movie ticket or railway ticketing, or you are making online transactions. All those are online applications. User involvement required, compulsory. But what all we discuss is user non-involvement. What are batch applications means? User non-interactive applications. User non-interactive applications, we call them as batch applications, where user
Okay.
is no way involved here, right? Means all our background applications which runs in the background. Most of the financial applications are background applications. For example, background application, simple example, for example, generating credit card bills for millions of customers. User nowhere required. User is not going to give any input here. Phone bill generations means a statement generation, right, for millions and trillions of customers, right? So here where user involvement nowhere required. So these are batch applications. So Hadoop is meant for batch applications, not for online or online applications, right?
So it will also convert the raw data into structured data. That is
Yes. What you can do is
like
ETL. You can
in earlier in we
like
use Informatica and all that
yes,
tools, right?
exactly,
So
And what I'm talking, that is ETL. You can do it. You can extract, you can transform, and you can load, right? You can just to pull the data from different data sources, from databases, OLTPs, right? You can pull the data by using scoop component here. Scoop is the component which works only for databases and Hadoop only, no other component, right? Scoop, SQOOP means first two characters from SQL it has taken, last three characters from Hadoop AI has taken, formed scoop. SQOOP, last three characters of Hadoop, first two characters of SQL. So it is for
So
import and
which
export operations.
distribution you will teach? Hello?
Yes.
Yeah, which distribution you will teach? Hadoop, that is a map, that is MapReduce and Hadoop. Is there a Cloudera or Horton? Which one you will teach?
Cloudera.
Cloudera. Manager you will teach, or individual things installation you will teach?
See, individual installation.
Okay.
So here, okay, that's what I'll also show you, like how to install all those and how to configure those components, right? And how to download and how to configure one by one component, right? If you install Hadoop only with say two components like MapReduce and HDFS only, but all the other components separately we need to configure. Means not in Cloudera. If you are using separately, if you want to know the installation process. Okay. So yes, that is what Hadoop is meant for: batch applications, millions and trillions of records if you are pulling from different databases, right? And next you are going to process with some business logic, right? After processing, right? You can storing and again taking the data back to databases, right? For that data ingestion tools available, right? Like we go for Scoop is one, Flume Kafka we can use, right? For streaming data, pulling some streaming data and just storing in this
Sir,
HDFS Hadoop.
like we have got
Yes.
right now, clouds are there, right? Amazon Web Service or Azure, the Azure Data Factory is being used, right? So the same concept is here in this Hadoop also. I mean, what is cloud here actually? So someone asks, now, so I don't have. Maybe
So
that person
cloud,
is an experienced person. So
no, not like that. The cloud, it's not. We are not going to learn anything like it with cloud era. The only thing is, it's a kind of where you are going to run all those things, right? Environment. So it's a kind of a distribution where you are going to see all the Hadoop related components pre-installed in that, right? It's a kind of environment where we are going to run and execute all the things, right? So here, one thing
so
is cloud era
nothing to
means
do
we
with
don't.
any cloud, right? Amazon Web
So
Service or
yes, see
Azure.
one thing, one second. So forget about it, right? So it's a kind of, don't think a cloud era means totally like cloud related everything, right? It's a kind of distribution where we are going to see all the Hadoop components pre-installed in it. So otherwise we are going, I'm just going, for example, for it's nearly like 35 GB, you are going to download it. But instead of that, right, people with low means people with, you require high RAMs for it. But I'm going to provide whatever I created. I have created a separate, means where you can see all the Hadoop components. I'm going to provide you with a VM image, right? Virtual VMware. So where you can work with all the Hadoop components and Spark components, even like Hadoop Spark with Scala, PySpark, all those components. Just I'm going to provide you where you can just download only 6 to 7 GB is enough, right? Because so not a worry, right? So everything we'll be discussing in brief. So we'll be spending more time on this course, right? Nearly we'll be spending 75 hours on this course. So in that 75 to 75 hours, right? Mostly my 45 hours I'll be spending on Spark and Scala, right? So here totally we'll be discussing about this. Spark is meant for processing. How do both it can perform storage and processing, right? Means for huge data storage and processing. Okay. Yeah. Any more queries you have got?
So for practical purpose, for our own homework assignment, like, so where we will get the data? I mean, there would be a huge data for processing if we want to do the practice, right? So, I mean, how can we do it? Because normally we can install standalone Oracle if you want to go, or if you want to run any SQL queries, or if you want to create table and whatever user, we can create it, right? So how can we do it in our personal laptop and in Hadoop or that is.
Yes. I'll provide you where you can get from that data, where you can get the data sets, and I will be providing data. I'll be forwarding to your Google Drives, right? I'll software related and data related, data sets related, everything I'll be forwarding to your Google Drives. And about software, not a worry, right? Even if you've got whatever system it is, right? I'm going to provide you multiple. If you've got a high configured or low configured, not a problem. Hadoop, I'll make you install in your systems, right? Hadoop and Spark both. So as part of the course, we'll be discussing Hadoop and Spark with Scala, right? First, I'll be discussing about Scala programming before I go with Spark's Scala control structures, Scala collections, transformations, Scala functions, all after discussing about Scala. I'll come to the Spark core programming, introduction to Spark, how comparison with different technologies, Spark data objects, RTD, computation, persistence options, Spark core computation, fault tolerance models, different ways of creating groupings and aggregations, right? Various inbuilt actions and transformations one by one with many working examples. And next is Spark SQL, making data structured and working with different data frames here, making data structured and working with data frames concept here. We have got many data frame APIs available. and working with different file formats also, CSV, JSON, integration with MySQL, integration with Hive, right, and many other things, right? Hive and HBase integration and deployment modes, local mode, cluster mode, right? Within the Yarn cluster, standalone cluster, Spark applications, stages and tasks, database and executors, and Spark submission, how we submit Spark jobs. So submitting and how to create jobs using IDs, like how to run on this Eclipse ID, how to run on IntelliJ ID, and using build tools like SBT build tool and Maven build tool, right? And also knowledge on Spark and Cassandra, right? Yes. So the timing of this batch, once again, I'm saying, right? So the timing of this batch, so for the demos are for 1 week like this, 1 week, 10 days, it will be at 5 p.m. But the timing of this batch will be at 6 o'clock. 6 p.m., right? Yes. 6 to 7. Daily, it will be at 6 to 7. But first 1 week, 10 days, it will be at 5 o'clock, right? Yes. Yeah. So tomorrow also you can attend the session to see more on this, right? I'll be just briefing you about the other things of how exactly the data storage and why only Hadoop can perform, why not the other things, right? Yes. Yeah, it will be from 6 to 7. From first 1 week, 10 days, it will be at 5 o'clock. Later, it will be at 6. Before itself, it is said, right? Yes, I'm saying here itself. Okay, fine. Any other queries, right? Anyone? So about the software, other
Sir, one
things.
doubt.
Yes, yes.
Sir, one doubt. Sir, is it better to learn Spark with Scala or Spark with Python, sir? Which one will be helpful for big data?
So yes, by default, Spark built by using Scala language. By default, Spark is built by using Scala. Everything Spark is designed with Scala language, right? But today, previously, only Scala was much used now. Even now, also both Scala, that is what Scala and Python both are used. But Python, like if you are going for helpful for machine learning kinds of applications, those things very much used, right? But now, but as per Spark is concerned, Spark APIs or Spark related, everything will be same in the same using Python or using Scala. Only the programming is going to change. It's a Scala is one programming, Python is one programming language. But the core Spark execution, the execution model, everything remains same. The inbuilt transformations, actions, everything, whatever we see in both remains same. The only thing is kind of programming is differ. It's going to differ, right? Yes. So even I take PySpark classes in the weekends, Saturday, Sundays, we have got PySpark batches running, right? So, but if both are used, right? But the only thing is Spark, you need to know how the Spark execution, implementing on which language, multi-language support. Spark can be, you can code it by using not only Python, Scala, using Java and R language also, you can code it. But Spark execution remains same in all this, right? Yes. Yeah, fine.
If you have both Scala and Python, it will be helpful, sir, in real time in the future.
Yes, yes. If you have got time to update, right? Even you can do that. Spark with Scala implementation and Python implementation, right?
Okay. So, in Python, do we require advanced Python also, sir? Core and advanced both?
No, not required. Normal basic Python and it required, right? Yes.
Okay. Okay, sir. Thank you.
Okay.
Hello,
so yes.
Sir, actually I'm working, so I won't be able to attend class all the days. So I will go through the recordings. So I will try to attend once in a week. But if I'm getting any doubt and I'm getting stuck somewhere, so how can I connect with you?
Yes. So in such case, any day you can attend. Otherwise, if you have got multiple doubts or many doubts, right, you can ask me for a time, right? I want some time if you want to clarify your doubts. A WhatsApp group will be there, right? For once all the students got enrolled, for the students to interact, right? So in that you can just ping me, right? So if you want any time in special, otherwise during the class, if 1 or 2 doubts, you can ask any one day. You can attend at the start or at the end of the session. You can ask. or if multiple doubts or if anything, you can just ping me, right, to ask for some time, right? I'll provide some time and you can clarify those, right? Yes.
Okay, sir. Thank you.
So recordings will be provided. Yes, every session is a video recorded one. You will be getting the session recording daily basis, and clear notes also will be provided. What all the practicals we do, I'll just forward, right, in a soft copy of those. Fine. Yeah, tomorrow also you can attend the session to see more on this, right, with the same link, same time, right? Yes. So if I'm done with your queries, I'll just sign off for now. Meet you tomorrow same time using the same link, right? Thank you all for your time. Thank you. Yes. Yeah, in the yesterday session, just I was discussing about what is big data, why Hadoop drawbacks with current databases, Hadoop and Spark advantages, Hadoop and Spark job market, right? Yeah. Currently, we have got a databases, right, for OLTP, online transactional processing, and we have got specialized databases like Teradata, Netija, Vertica for data warehouse purposes, which are used for analytical processing, right? Yes. But either databases or specialized databases cannot support unlimited or huge data, right? So as a solution that for all the storage level and processing level problems, right, we have got a framework called Hadoop. So generally Hadoop is meant for two things. Hadoop is meant for first storage. Yes. Hadoop is meant for processing. It is meant for storage and processing. For storage, Hadoop doesn't use any database, right? Because databases has got some drawbacks as I was briefing about. Yes, storage. So it is going with a special kind of file system called Hadoop distributed file system. And for processing, it is going with an execution model called as MapReduce. Or we go for Hadoop, or what is that, Spark, right? Yes. So processing, MapReduce or Spark. For storage, HDFS, right? Hadoop distributed file system. So Hadoop can perform both storage and processing. Any technology performs either storage or processing. but Hadoop performs both storage and processing. You may ask why databases can't be used? Why databases can't be used for storing Hadoop data? Drawback with current databases. And before that, as I was saying that Hadoop is meant for batch application. See, one thing what you need to understand, Hadoop is not for online applications. Hadoop is not for request response. Hadoop is not for client server. Hadoop is for batch applications. Batch applications means millions and trillions of records, right? Processing millions and trillions of storing and processing, right? Batch Hadoop is for batch applications. For one record or one transaction, right? Hadoop is not required. If you observe, right, there are two types of applications. Two types of applications, right? Yes. One is online application and batch application. Batch application. Online application, user interactive. What do you mean by online user interactive application? User interactive application. Here user gives the input, right? Yes. Here user gives the input. Yes. Here the user gives the input. Example of online application, right? Yes. Booking a movie ticket. Yes. Booking a movie ticket. Making a online transaction, right? Yes. Making a online transaction, right? Yes. Yes. Batch application. Batch application. User non-interactive application. User non-interactive application, right? Yes. User non-interactive applications. Here user is nowhere required. Here user is nowhere required. Example of batch application. Credit card statement. For millions of customers, right? For millions of customers. Credit card statement generation for millions of customers. Yes. Mobile statement. Mobile statement generation. For millions of customers, right? Yes. For example, if I give an example for batch application, for example, if you are booking a railway ticket, right? Your waiting status, PNR status is 200. After 1 hour, it is 170. By today night, it is 120. Tomorrow morning, it is 70. Tomorrow evening, you got confirmed, right? Means it is here user not giving any input here. It is a background application which runs in the background, right? Okay. Most of the financial applications are batch applications. Most of the financial applications are batch. Yes. 1 second. Yes, observe here. Online and batch application. Hadoop is for only batch applications, right? Yes. And if you talk about why databases are not used for storing Hadoop's data, what are the drawbacks? Means limited storage we see in databases. Most of the databases, no parallel processing. If volume increases, speed decreases, right? If and I just given with an example, right? I've just showed with an example. If you observe query to query, if you observe this query 1, 2, and 3, yeah, I want sessions to be interactive, right? Yes. Try to respond which query executes faster among these three. Yes. Total amount from sales 1, sales 2, sales 3. Sales 1 has got 10 records, sales 2 has got 1 lakh, sales 3 has got 1 crore. Total amount of 10 records, right? Yes. Total amount of 10 records, right? This query executes faster as compared with the other ones, right? Yes. Yes. So query to query, as volume increasing, speed decreasing, right? Complexity increasing, speed decreasing. Observe here. To sum of amount from sales 1, average amount from sales 1, standard deviation of amount from sales 1, right? So average, see, if you see which query executes faster means again the first query, right? Because average amount is a two-step process. First sum to be calculated, next average to be calculated, right? Yes. Standard deviation of amount, right? So a lot of internal processing required. So as compared with this first and second query, third query is going to take more time. And a major drawback with databases, they can handle only structured data. They can handle only structured data. They cannot handle unstructured or semi-structured kind of data, right? So before I go with Hadoop advantages, just I'll brief you, right? Hadoop, what do you mean by Hadoop cluster? Group of CPUs. Group of CPUs means nodes, we say. Group of CPUs, nodes connected in a network. Connected in a network, right? Yes. Group of CPU nodes connected in a network. There are two types of nodes. There are two types of nodes. Master node and slave node. Master node and slave node. In Hadoop, data stored by the slaves and data processed by the slaves. Then what master node does, right? So everything done by the slave node only. Data is stored by the slaves. Data is processed by the slaves, right? Observe this diagram, right? Yes. For example, I said Hadoop follows master and slave, single master and multiple slaves, right? Yes. Single master and multiple slaves. Slave 1, slave 2, so on up to slave n, right? This is the master node. These are the slave nodes. In database, data is stored in the form of tables. In database, data is stored in the form of tables. In Hadoop, data is stored in the form of files. f1.txt files, f1.txt, right? So this, for example, each slave 1 TB of capacity, its storage capacity 1 TB, assume, right? But this f1.txt 2 TB, right? Assume the size is 2 TB. Can it fit into any of the slave? It cannot fit into any of the slaves, right? Slave 1, slave 2, if we got 100 slaves also, it cannot be stored in any of the slaves, right? So in Hadoop, data is going to be divided into parts. Two advantages you are going to see here. If you are dividing the data or file into multiple blocks, multiple parts, two advantages we see, right? And you are storing across the slaves. You are storing across the slaves. So here 2 TB file can't be stored, cannot be accommodated by any slave. But if it is divided into smaller parts, stored across multiple slaves, data is distributed across multiple slaves and data is processed by multiple slaves parallelly. Think that a 10 lakh records in this, 10 lakh records is stored in this, 10 lakh in this way, every slave storing some lakhs of records. So all the slaves are executed parallel, all the slaves are executed parallelly, right? They are going to execute all the tasks parallelly. Parallel processing, you are going to see very high speed because Hadoop has got high speed because of this parallel processing. And secondly, Hadoop, how Hadoop is able to store huge data means data is going to be split, distributed across multiple machines, multiple systems, right? And is processed parallelly, right? And here data is stored by the slaves, data is processed by the slaves. What are the master node responsibilities? So master nodes assigns tasks to the slaves. T1 task, T2 task, T3 task, executing this 10 lakh records, this 10 lakh. Okay, T1, T2, T3 task. Who is assigning? Master to slaves. And load balancing, balancing the load, right? Assigning equal tasks to each and every slave. Fault tolerance. Fault tolerance mechanism means while 3 tasks are executed by 3 slaves parallelly, suddenly if any one slave goes down, if any one slave goes down, then the task of that slave T2 will be assigned to any of the other slaves. Who does this? Master. And before master assigning the task to the slave, first it will check the health status. What is the health status of each and every slave before it assigns, right? Yes.
Sir, one clarification.
Yes.
How does it know the status of the slaves? Is there any agent installed on the slave that will provide a regular information to the
Yeah,
master?
see, actually, I was just giving an overview, right? Lot of things we need to discuss internally, right? Hadoop
Okay,
architecture,
okay,
storage architecture, processing architecture. Just to know the Hadoop advantages, just I'm briefing you. Hadoop doesn't follow client server. Master slave means you will have single master, multiple slaves. But lot of things we'll be discussing. Hadoop storage architecture, Hadoop processing architecture. Again, within this master and slave, we'll have job tracker, task trackers. Job tracker assigns the task tracker executes the task. More precise way, right? We'll be discussing in the Hadoop architecture, right? But as of now, Hadoop follows master slave architecture, single master and multiple slaves.
Sir, is it always a single master?
So, but from Hadoop 2 version onwards, there is a high availability concept was there. There is a new feature we got, right? High availability, HA. High availability means multiple nodes we can have. Multiple, right? Even for example, if one slave goes, we have got another slave. But from Hadoop 2 version onwards, so there were some architectural changes. So I'll be discussing both, right? Both architectures so that you will know what was previously and what was now. So how was the architectural changes? We can go with the multiple nodes, name nodes, right? Internally, again, for storage, we got a name node, data node, secondary name node. Again, for processing, job tracker, task tracker. Okay. Again, in the latest architecture, we have got a lot of components like resource manager, application manager, resource scheduler, job history server, application master, node manager, container, right? We'll be discussing what each component and how the processing is going to happen step by step. Okay. Fine. So as of now, master node responsibilities, right? Yes. First one, task assignment. Load balancing. Fault tolerance. fault tolerance means when multiple slaves executing multiple tasks, suddenly if any slave goes down, then the task of that will need to be assigned to any of the other slave, right? And health monitoring, right? Yes. So you asked, right, one query. So heartbeat signals between the master and the slaves. If the signals are missing, then immediately it thinks that the particular slave is down. Immediately the task will be assigned to other slave. Okay, now just observe this Hadoop advantages, unlimited data storage. Unlimited data storage because of horizontally unlimited scalability. Horizontally unlimited scalability. Horizontally unlimited scalability means, observe.
Like we can add new systems.
Yes,
So-
yes. You are running with a less number of slaves. Slave 3. You are running with less number of slaves, but for example, your customers are increased, your data is increased, your business increased, your branches increased, data increased by 100 times, customer increased by 1000 times. You cannot go with the same number of slaves, right? So horizontally you will be increasing the slaves from 3 to 30. So if horizontally increasing the slaves, horizontally unlimited number of slaves, horizontally unlimited number of slaves can be added. Okay, storage point of view, just observe here. You may ask, why only Hadoop can perform
Slaves are the servers, or I mean, what exactly is master slave architecture? I mean, so master is any, I mean, server. I mean, there are some sub servers. I mean, how it is defined?
so just a group of CPUs, right? If you have got some 40 node cluster, one will be behaves like the master, the other will be as the slaves. 39 will be the slaves. Means you will be configuring so master and multiple slaves. Uh, in all that master and slaves, you'll be having all the softwares be installed, but total monitoring, everything will be taken care by the master node. So okay, I'll just discuss more on this, right? Architectural part, storage and processing in that Hadoop architectural part, storage and processing. Observe here. You may ask why databases like Oracle? Why databases like Oracle? Cannot support unlimited storage. Cannot support unlimited storage. Why databases like Oracle cannot support unlimited storage? If you observe, right, even for databases, right, for example, like Oracle, in real time, we can go with multiple slaves. Databases, max limit on number of slaves. Max limit on number of slaves. Why databases like Oracle cannot support unlimited storage? So